Water is a ubiquitous resource on Earth that is necessary for all living species, but quite often taken for granted. All the way back to the agricultural revolution, water was needed to have a successful city.
Basically allowed people to settle down, whether it is up in a mountain area where they have a little creek that they can divert and water fields, or it could be something like the Nile River where they were able to use it on a grand scale, irrigation.
The first example of an urban society was Jericho and was very purposefully located near freshwater springs and other sources of water. Eventually, civilizations advanced and invented wells, stone channels that collected rainwater, ceramic pipes, and later on toilets and running water, which was used by the Romans and the Greeks.
Biggest thing with both of them is they were on the Mediterranean Sea, so that would be salt water, obviously, but they used that to their advantage mainly for trade and for conquering other lands.
But back at home, these cultures were more concerned with accessing clean potable water, and when clean water wasn't available, they filtered it and boiled it. The people of antiquity also used water for irrigation, and a lack of water could lead to droughts and famines. But these weren't the only civilizations that depended on water.
The Nile River civilizations in Egypt, they were a vast civilization because of the access to the river and the sea. Tigris and Euphrates also allowed Iraq to really prosper early on too.
Settling down near coasts is still necessary for urban cities today, as 40% of the Earth's population lives within a little more than 60 miles from the coast. This could be to humans' detriment, however, as sea levels are rising and flooding in coastal cities will only get worse due to climate change. It is not currently an imminent threat, but the choices made today will have an enormous impact on the lives of citizens 20 years down the road. It is a transparent, tasteless, odorless, and almost colorless compound, so how could it be so important?
As far as we can tell, water is required for all life on Earth, and specifically liquid water. It helps with so many biological functions, how it dissolves everything so well, so it's really good at transporting things around organisms.
However, water doesn't supply any calories or nutrients for the body.
So while water doesn't supply any calories, it does move things around in the body. So whether it's a plant or an animal, water is a mechanism for transporting a lot of the other molecules necessary for life. So one of the unique things for water is that we call it the universal solvent. It is a polar molecule that's really good at dissolving things. Because it can dissolve so many things and transport them around, it's really good at moving and chemically manipulating things in ways that are very beneficial for life.
As well as being used for transportation of nutrients, water is also very good at cleaning things and is used in showers, washing machines, and dishwashers. It is also a main ingredient in cleaning solutions because of its properties.
So water is a polar molecule, which allows it to dissolve other polar molecules, but it also lets it dissolve any sort of ionic compound. And so it's often called the universal solvent because it just dissolves so many things so effectively.
As well as being very effective at dissolving things, it is also very abundant on Earth, but no one is positive where it all came from.
There's actually a lot of current speculation talking about where the water on Earth came from. So there are some chemical mechanisms that are likely to have existed early in the formation of the planet that created water. However, the amount of water that's on Earth is not consistent with those mechanisms alone. So right now, the speculation is that water came in from outside of Earth. There are, I believe, two main mechanisms. One's comets and one's asteroids. And I forget which one is speculated to be the bigger portion, but basically stuff crashes on Earth and drops off water.
And this water covers 71% of the Earth, but still there are billions without access to clean water.
Supposedly, like half the globe does not have access to clean water, so it's a huge problem. I have a friend just recently, he lived in Myanmar, and until he was 10 years old, he would go to the river and get buckets of water to drink. He's in his mid-20s now, and that's pretty common in underdeveloped countries to use water, drinking water from a pond or another river, place that isn't clean. It's pretty common and obviously not healthy.
Even though water is so plentiful, only 2.5% is fresh water, and the other 97.5% is salt water and not safe to drink.
So humans can't drink salt water because of basic ideas of concentrations. So things move from high concentration to low concentration, and if there's salt in the water, then water's actually going to move out of the cells in your body, and so it actually dehydrates you. Separating the salt from water is always going to take more energy, so it's an energy intensive process. It's not that it's actually difficult, it's that it's difficult to do it cost effectively. There's not a way to do it cheaper than to, drill into the earth and tap that water that's already clean.
Another issue that is prevalent today is pollution, the prime example of which made international headlines.
It's a public health crisis of massive proportions. Lead in the water supply in Flint, Michigan.
This crisis was caused by a cost-saving maneuver made by a local government to use the Flint River water, and due to a lack of regulation, they were not required to add an anti-corrosive agent to the water. The water ended up being highly corrosive, leading to the water eating away at the pipes and causing residents to get rashes, hair loss, and more. This was because of how water interacts with the body.
So everything pretty much needs water, and so when other chemicals get into water that interact in a similar biological way as other things, they can disrupt biological systems, and that's what a lot of pollutants do. There's also all sorts of other pollutants. For example, even just a change in temperature can be a pollutant to water because it changes how other things interact with water. For example, raising the temperature of water reduces the amount of dissolved oxygen in the water, and that's bad for aquatic life that relies on the oxygen in water.
The rising temperature in the ocean is a major problem, as well as the acidification of seawater due to released carbon in the air. When this carbon dissolves in water, it creates an environment with higher hydrogen levels, which leads to a more acidic ocean. This acidification is leading to coral bleaching in the Great Barrier Reef. As well as acid in our oceans, an increase in acid is also present in our rainwater.
One of the main ways that acid rain forms is in the release of sulfur compounds into the atmosphere. So a prime suspect would be like a coal-burning power plant. And if sulfur compounds get into the atmosphere, they react with oxygen and eventually form sulfuric acid as they react with water in the atmosphere. And the effects of acid rain are numerous, but basically you're just lowering the pH of the water that's touching stuff, and so it can have an effect on anything living because it disrupts biological systems, but it also has effects on things that people have made where it can degrade statues and sidewalks and all sorts of things.
Clearly, water is an important, omnipresent force necessary for every person, plant, or living thing on this earth. It is a large factor of success for all ancient and modern civilizations that utilized it in new and exciting ways. Even though water is quickly accessible in almost all U.S. households, it should not be forgotten that it is the solvent of life and a vital substance for a healthy population and economy. Consider that the next time you pick up a glass of water.